Nope. Now we're going to go ahead and get started with the recording. So out there on Blackboard, you'll have week 4 out here. This week's going to be about NumPy and SciPy. And so as I was explaining to a couple of the computer science majors in here, I'm not going to go like super deep down the rabbit hole on NumPy, SciPy, right? My goal is to get you the introduction to it. You understand what it is. In the real world, unless you're doing things like data science and mathematical calculations and things like that, you're probably not going to be writing natively in NumPy and SciPy. You're probably just using it as a package that you install, and then some API is going to take advantage of NumPy and SciPy. So if you're doing strong data analytics and all that kind of stuff, they're actually going to dive super deep into that. I'm not trying to make this a data analytics course. We have great data analytics courses, and I encourage you to go check those out when we do that. So to get started on NumPy, SciPy in this week, if we click out here on, I'll actually switch over to the virtual machine here and take a look at NumPy, which is that first link that's out there. So out in the documentation link. I'm not going to do fancy slides and things like that, because when it comes to NumPy and SciPy, you need to know where the documentation is, right? Like I can give you fancy slides and say this is what it is. It's great for notes, but the truth is when you guys go to reference it later on in life, you need to know where the documentation is. So this is going to be the documentation link. The link that's up there at the top is set for the stable version, which means it's always going to be the up-to-date version, right? So when we talk about different packages and such, in the upper right-hand corner, you're going to see all these different packages within Python and just about any language is all going to have versioning in it, right? And so this is going to tell you that you got the development version, you have 1.23, which is the stable version, then you got all the old versions. It's important to go find this kind of stuff, especially if you're using old example projects. You may have to refer back to older documentation for the version that you're working with. It's pretty commonplace for most of you that have worked with it, but there's maybe some students in here that are coming straight from 360 that don't quite understand how that versioning works. So this will get you into NumPy. NumPy itself is basically called, it's referred to as the mathematical package for Python. It's going to help you with scientific computing. And it's going to provide multi-dimensional array objects that you guys can use, as well as various derived objects such as masked arrays, matrices, etc., that have an assortment of routines and fast operations on those arrays. I lost like half the audience, right? Because this is like super deep math is really what it boils down to. So if you need to do super computational stuff or statistical operations or advanced basic linear algebra, that kind of stuff, that's all going to be in NumPy. When you work with NumPy, you're going to be working with what's called an ND array object, and this encapsulates your X-dimensional, or in this case, N-dimensional arrays into homogeneous data types. Fun word, right? That is the key word when we deal with data types in NumPy. So it's going to, array in NumPy is going to be like a Python list, only it's going to be homogeneous across the part of it, and it's going to be super fast and computational. That's the layman's version of why use NumPy over a Python list. They function the same, only there's going to be a whole lot more discretion or things available to it in a NumPy array. All right. As you get started over here on the left-hand side, to install it, you typically use just pip install, and you can pip install NumPy. There's also what's going to be conda here. And so that kind of leads me into the next discussion. If you come out here, you're going to see Anaconda. Anaconda out here is basically a distribution of Python that's specific for doing scientific computations, right? So particularly if you're going to do any kind of data science, you're going to use this with R, or if you want to do I just forgot the word. You and I were talking about it the other day. Machine learning, thank you. So if you're doing machine learning, doing Python with R, that kind of stuff, you're typically going to use an Anaconda repository or an Anaconda distribution of that. You'll notice that built into that, you're going to have these packages that we've been talking about. So things like SciPy, things like NumPy, things like PyTorch, TensorFlow, that kind of stuff. Those are all common when you're starting to talk about that. Matplotlib, we're going to talk a little bit about that here today. And pandas, we actually have a whole section talking about pandas data frames and such. So you can go out and install Anaconda directly if you want to, or you can use your own distribution like we have been doing within Python and PyCharm and all of that, and just install the packages you want. I'm going to go ahead and just walk you through the Anaconda distribution so you have an idea of what it looks like. Once you get it installed, it has its own package manager called Conda. And so Conda is essentially going to replace what you would have done with pip install back in the day. All right. So you can go in here, you can click on the links, it'll get you to the download on it. And you can get different plans and pricing and all that kind of stuff in there. You really don't have to use that kind of stuff. You can just use the free Python install kind of thing and get that up and running. So I lost my link. Where'd my link go? Conda download. There we go. Okay. Down here in the 64-bit one. Now you'll notice it's a little heavy. It's almost 600 meg. That's because all these Python distributions or these packages are included in this distribution. So unlike Python, which is just the nitty-gritty basics and that kind of stuff, this is going to have a bunch of packages already installed. I want to install this because I wanted to show you how you can integrate it with PyCharm real quick. Now, you don't need to do this for the purposes of what we're doing for this class, but you should be familiar with this, as there will be projects you will come across in Python that will use Conda, and it would be better to install Anaconda than to try to build everything out. Thank the school for the fast internet. Not missing anybody. All right, so we walked through the install. It's pretty basic, just like what we did with the Python installation. The only difference here is you can add path or add Anaconda 3 to the path. They don't recommend that you actually do that for Anaconda, that you should actually go into that environment and do that. So we won't actually click that checkbox like we did back with the Python install. Quick little install. So while this is getting set up, again, Conda is going to be very close to pip, which means right now, when we've been working in PyCharm, we worked with what were virtual environments, right? So every project has its own virtual environment. That's a way of keeping track of the packages just for the project that you're working on. Conda is very similar. So once we get this set up in PyCharm, you'll actually change the drop down to use virtual environments. You'll actually tell it to use Conda if you're going to do an Anaconda project. Let's see while this is doing its install. So today we're going to go through NumPy and SciPy. We'll kind of get you an example of what's going on. We'll plot some things out, that kind of stuff. On Thursday, you guys are going to get the little mini project for this week. And then we'll also have a quiz. And that quiz is just going to cover everything that we've talked about here on NumPy SciPy. It'll be a pretty simple quiz. It'll be probably 10 questions kind of thing, nothing over the top. And the quizzes in here are going to be open book, open note stuff. So you'll have, I think it's 1 hour to complete it. And then it'll ask all the questions at once. It's not going to be like a question. I've tried doing quizzes where I ask for you to do computations and things like that. That fails miserably. So these will mostly be multiple choice style questions. It's your project that's really gonna show something out there. I wanted to walk through the first project because we're gonna post it up to GitHub and do that kind of stuff. So as you guys are working through that. Obviously, this base install is taking way longer than it did when I did the demo 5 minutes ago. Before class started. So we'll let that keep going. Back here on the NumPy side, again, this is going to tell you how to install it. So in Conda, you're basically just going to create a new virtual environment using Conda. So you can do this from the command line. You can do this from within PyCharm, and you can add those different things in there. And there's different channels within Conda. This is going to allow you to install, you can think of them like repositories, and be able to install different packages inside of there. Otherwise, it's just a straight pip install NumPy. Come on, base environment. So again, if you scroll up here in these details, you'll see all the packages that they're throwing in here. They're going to use things like Jupyter notebooks, things like that. We're not necessarily going to cover Jupyter notebooks in this class, but it is something you should become familiar with. So where are we going to use NumPy, SciPy later in the class? We'll use it when we start working with pandas, when we need a little bit of crunching data. And we'll use it when we work with Streamlit, which is allowing us to work with data frame sets. In this case, we're actually going to pull like stock information and display it out on a dashboard, that kind of stuff. Again, in the real world, you're not really doing hand coding in NumPy and SciPy or using it directly. You're usually using it via a third-party package when you're installing it. This is obviously going to take a little bit here. Other stuff I wanted to show you over here on the left-hand side, we will talk about this link here where it talks about the absolute basics, right? And that's going to talk about your ND array. When we import NumPy, what we always did in like INF601 and such is we just said import NumPy, right? Or we did from NumPy import something inside of there. When you import NumPy, this is typically going to be in this fashion here where you have import NumPy as NP. Now, you can do this any way you want it. I could say import NumPy as potato, and then I just have to use the word potato for every time I do it, right? Doesn't matter what I use. However, the widely adopted, widely used standard for NumPy is going to be NP. Makes perfectly good sense. But that's the convention, and that's what you should do in order in all your code so that people know when they import it, that's where it's coming in at. When you read different code within NumPy, this is pretty common here. Again, I could use you all sorts of fancy tutorials and this and that. It's better to understand where the documentation is. So here we can say that we're setting a variable of a equals np for NumPy dot arrange 6. And then we're going to have A2, which is taking that arrangement or that array, and we're going to set it on a new axis and create a shape. All this is going to show here is that I can copy and paste this, and these three greater than signs are indicating this is something you type in, where these ones without it is indicating something that should be returned back to you. Most of you should know this. It looks a lot like what you would see on an IPython terminal. When you're interacting directly within the code, that kind of stuff. What's the difference between NumPy and SciPy list? I kind of talked about that earlier. NumPy arrays are much faster and more compact than a Python list. So hint, hint, wink, wink, that may be a question on a quiz. That NumPy arrays are faster and more compact than Python lists, all right? Those arrays will consume less memory, and therefore it's more convenient to use. Because it uses much less memory to store the data, it provides a mechanism of specifying the data types, and this code allows it to be optimized even further. So it comes down to when you're doing computational math, you want it to be as precise and as fast as possible when it's loaded up into memory. All right. That's kind of the gist of what I wanted to show you here. We will go down and show you a little bit of the arrays, and I want to show you the matplotlib section because that's really what you will see most of this out here. That's the matrixy stuff here. There is a section here for generating random numbers. If you guys remember when I talked about random numbers, even back in Python 360, that you'll know that if you import random, right, and then you get a random integer, it's not always random. A lot of times it gives you back the same number multiple times in a row. Here you can create this massive array of doing that, and then you're going to pull out numbers inside of it. More often than not, you'll get a more random number out of that. And so that's another reason you can use NumPy, is if you really need a big number, then you can create this massive array, and then you can have it generate a random number back out of that. That's pretty common to use. We got uniques you can count out of there. That's one of the main reasons or things that I've used Python in the past, is if I get a bunch of numbers in a list or something like that, right? And I want to figure out which ones are unique or how many of these I have or how many unique values, you can use NumPy to calculate that stuff really, really fast. So we'll go through there. I believe Conda is done. It is. So we'll hit next. We'll finish, get this closed. And we'll worry about the tutorial another time. Okay. So if I come over here in my start menu, it's going to be similar if you're anywhere else, but if you go to a Anaconda PowerShell prompt, this is going to be very similar to what you're using when you're using, remember idle when we first pop it up and you're going to have that interactive shell, same stuff here. So we'll get this popped up. Back to our installation. And again, if you're using this in Conda, you'll want to create your virtual environment. Sorry, I still have a nasal from last week. You'll need to activate it so that you're in that virtual environment. Then you can set up a config to pull from the right channels. Then you can do a Conda install NumPy. Very similar across there. So we got this up. We can see this here. Notice that we are in the base virtual environment currently. So if we create a new one, we can do Conda create -in, and then we can call it whatever we want. So if we call this my NumPy, like that, it will create a new virtual environment for that. Yes, that's all fine. Okay, then we need to activate that virtual environment. Again, notice that we still have this base over here. This means that we're working on the base operating system. So Conda activate my NumPy, and you'll see that base change over. Whoops, I didn't spell that correct. Conda activate. Okay. There we go. Again, you'll notice my NumPy is now here at the front. That's how you know you're in the right virtual environment. And then from there, you could add the config. In this case, we're just going to do a Conda install NumPy. And so it's going to pull from the repository, get it all up. Notice that NumPy itself has a ton of other dependencies on top of it. So we're going to go ahead and hit yes to install all those extra packages. And we'll go ahead and download and extract and install all those in there. While that's going in there, again, that's just how you can get started in there. Then in your project, you would make sure you do import NumPy as MP as you pull it in. Where we talk about Conda here, I did want to pull up PyCharm real quick. Those. Anybody have any questions on any of this so far? No, it's pretty straightforward stuff. All right, so again, in this case, we're going to start a new project up here at the top. We're going to be using just pure Python as we go through here. Now notice, if you look over here on the left-hand side, if you're using PyCharm Pro, you do have a scientific one here. If you click on scientific, it's using an Anaconda environment. That's its whole point. So you'll notice up here at the Python interpreter, you're going to have a new Conda environment. It's going to use the environment from Conda, and we had installed 3.10. So if we click on this, or you could do a pure Python, you could change this down to Conda. It's going to do the same thing. So you can click on scientific over here. You can also set more settings for setting up a data folder and some extra stuff. So this is how we're going to set it up. This scientific project, we're just going to say my NumPy project, hit create, say this window. And so this is going to create a whole new Conda virtual environment, different than the one that we just did here at the command line. But this one will be tied to our project inside of PyCharm. So get this up and running. Again, it's better to work in virtual environments. If you do this out here in the main one, then it's pretty much there for all of your Conda stuff, right? So you're going to have confliction between different projects as you work through there. Okay, so we have this up and running here. We can see the Python down here at the bottom. Notice that we are running Anaconda in order to do this Python. There's a couple of caveats there. So when you install like Anaconda, and in this case we did 3.10 or 3.9, a lot of times Conda, when you're using NumPy, requires an older version of Python. So there'll be times where you'll even see you have to go clear back to the 2.7 days in order to get some of these packages to work, and it will automatically install that. All right, so if we come down here, we go to Python packages. Remember that you can install NumPy this way, so you can do a search for it and install it here. Or if you go to the terminal, this first time it loads, it takes forever because it's building out all the references to all the different packages and whatnot. So. Okay, so in this case, it didn't set up the Anaconda environment like it's supposed to. So you could set up the Conda in its shell, and it would go ahead and put it up there. If the packages, you could go ahead and install NumPy. So if we put NumPy in here, NumPy, there we go. We can click on this package, and we could install it. Now, it should be installed by default. We'll look in here, but it should already have been installed. Again, what's nice with PyCharm, ignore that, is you will get all the documentation stuff built right into PyCharm, right? So as you're working with the NumPy documentation, it can be built right into the inside of it here. Set up all the interpreter, do this little install. Okay, so NumPy is ready to go. Up here at the top, we would say something like import NumPy as NP. And then there again, we would use NP anytime we wanted to create things. You'll notice over here on the left-hand side, you're going to have folders that are already created for this. So you'll have a requirements.txt file already built out for you, a README file. You'll have the data folder that you would shove all your data in to collect and pull this kind of stuff. One thing that PyCharm does make this a little handy, if you click on this side view over here on the right-hand side, as you are building out different models and arrays and stuff, it will allow you to view those, and you can actually plot that data out right here in PyCharm, as opposed to having to use matplotlib and some other stuff. So again, if you're going to go really off the deep end and start doing a whole lot of machine learning, and you're going to do a whole lot of data science and using R and all that kind of stuff, PyCharm's super powerful to do that. You can use all these extra features that are inside of that. Okay, we're going to close this down for the time being, though. We're going to close the documentation. All right, let's come back to what we were showing in here. So that'll get you NumPy in here. SciPy, you'll have that link out here from the content. SciPy is basically an extension of NumPy. So installing it is very similar to NumPy. You're going to either do a conda install SciPy or a pip install SciPy. So what is the main difference between those two? If you click on this handy link here, this is going to better explain it more than what I can do. And this data flare does a pretty good job of not only explaining the difference between the two, they have some really good tutorials over here on the left-hand side. So I encourage you to kind of explore a few of those as you go through there. You'll get more familiar with the two projects. But the idea is NumPy is going to stand for numerical Python, where SciPy is going to stand for scientific Python. Both of those functions are written in Python. NumPy, we're going to use those homogeneous arrays operations. We're going to use that for manipulation of elements of numerical data array, where SciPy is more common for scientific methods. It has a bunch of sub packages and a collection of functions in there. So what's the fundamental difference? SciPy is built on NumPy, and all of that numerical code is going to reside in SciPy, and SciPy is slower than NumPy. So when you do a bunch of computational stuff, NumPy is going to be much faster. All right. It's generally used for the basics of like sorting, indexing, and array manipulation. The important feature of NumPy is its compatibility. It works with a lot of different other languages that are outside of there. All right. What was the other key things? Let's see. Concept arrays, that's all fine. So NumPy itself is written in C, therefore itself, and therefore you're going to have a much faster computational speed. Although NumPy features are in SciPy, we prefer to use NumPy when working with just basic array concepts. All right, super simple. There's way more in depth that you can see on all of these down here on the left-hand side, and showing how to go in there. We're going to use matplotlib, so let me get back to that side of it. To the NumPy. So you're going to have MathLab, which is a whole different ball of wax, right? We're going to use matplotlib, which is the next one in here. Get this pulled up here. This is really what you're going to see when you guys import it and use it. So when we build out an array like what we have in here, we're going to have something like this. Just copy this in here. Okay, so we have an array, NumPy array here that's going to go 2, 1, 5, 7 all the way through there. And then what we want to do is import matplot. So if we come in here and do matplotlib, which is this one here, we'll go ahead and install this package. Matplotlib is typically used for graphing things. So you can either graph 2D arrays, you can graph 3D versions of those graphs. But this is typically when you're using computations inside of it. So we'll get that package installed. This is typically how you will see it imported in. So once we get this package up here, we're going to put this up here underneath our import array. So we're going to import matplotlib as PLT. Again, this is all kind of a universal standard. And then a very basic level, we are going to say plot this array that we have up here. So we'll get this running here. I evidently didn't give enough CPU cycles to my virtual machine. Let's see, you folks online, do you guys have any questions?
No.
All right. Finish getting this package installed. So I'll try to dig it up because I had a really good computer science student that did their project in 360 with this. And what they were doing was crunching a bunch of different information that came out of arrays. They were using it to start playing with machine learning. And so they had a bunch of array data that came in. And then you can use matplotlib to create a bunch of different graphs. So you can do that in 2D, 3D. We've all done it in Excel and things like that, but this is how you would do that with Python. If you generate those graphs and then you can save those out as graphics, you can save them out for HTML websites, so you can build those graphs and visualizations out. I don't know why this is taking so long to install. I had this all installed before class, and I remember that you have to show how to install it. Okay. Looks like we should be up to speed now. So if we go ahead and click run. Should get a plot to pop up here. So if we click on this down here at the bottom, when it's running, you'll notice that you have this ND array. If you click on view as array, then we can see this data up here at the top. Again, this is the beauty of PyCharm. So we can see the array data. Now, obviously, we just have one simple array in there, but we can use that to manipulate and see how many of those are in there, what slot they're in, that kind of stuff. We can do filtering. If we look at plots, we should be able to see the plots, which we do have one. I'm not sure why it's not pulling up there, but it should pull up. Try this again. Okay. She'll love it when it doesn't work like it's supposed to. Let's see here. Should plot right up. All right, so if this worked like it was in, helps if you do the show, right? All right, so we created it, guilty show. That's what I was missing. There we go. And so now in the plot, you'll actually see the chart as it graphs up through there. And then in this case, it automatically generated it as a PNG file. You could play with some different settings and have it adjust and create it however you want. So sorry, I forgot the show portion of that. All right, so you can see this and it's graphing the chart. Again, this is when we start to get into the stocks and the other information where we're actually taking this array, but in this case, it's going to be the pricing of stocks over time. And we can take the chunk of like an entire year on a daily basis. That way we can get a nice flow chart as it goes all the way through. All right. If you look further down, you could do things that will allow you to do like line spacing graphs. You can tell it to do dots. You can tell it to do it in different colors, usually by indicating this third tuple here. So as you're passing this in, or not a tuple, argument as you're passing through there. So you can plot your X, Ys as it's going through. You can say that the line's going to be in purple and your dots are going to be those. So you can see that. You can also do some nice 3D visualizations here where you can do, very advanced constructs and things in there. All right. Anybody have any questions on NumPy? Again, SciPy is just going to take it one step further if you're going to do more data crunching, that kind of stuff, pulling that up. So I'll pause here. One other piece of it is these are the different applications in NumPy. You'll see this picture up in the Blackboard side. So you can use it for alternative to lists, again, because you can use it to organize. You can use it to plot or make, multi-dimensional arrays, specification, all that kind of stuff. You can use it with matplotlib if you want to do graphics. You can use NumPy with pandas, which again, pandas is something we're going to talk about in the future. You can also use it with tkinter. Tkinter is going to allow you to use as a GUI. So we talked about different GUIs. We won't be using something like tkinter, but if you want to write your own graphical program, then you could do that with tkinter and other mathematical arrays. Does anybody plan on doing their project? And I specifically brought this up for you comp sci majors. Are you guys planning on doing stuff with NumPy, SciPy, the ones that are in here? Okay. So not natively, but it may be part of your package that you're planning on. TensorFlow, okay. How about any of you folks online?
Not that I'm familiar.
Okay.
Not sure.
No problem. So in the cybersecurity realm, like what we're talking about, Sam, every now and then you'll use this in a little bit of cryptography and stuff. If it's using number crunching, things like that, we'll use the NumPy package, but we don't typically work directly with the arrays and such. It's usually a third-party package using NumPy to accomplish what we were trying to do.
Okay.
All right. So key for everything today, I know again, it seems very fast. We will have our project that we'll kind of walk through on Thursday because I want to get that first one out of the way where we walk everybody through it, we calculate stuff, and then you guys can post your code up. And then we'll have a quiz on there as well. It'll just be a 10-question quiz over the topics that we did today. So big thing is going to be the difference between NumPy, SciPy, understanding what Anaconda is, the virtual environment comparisons, that kind of stuff. That's what the quiz will be over. Anybody have any questions over the stuff this week? Now, when we get into, like I said, for you comp sci majors, if you're going to do this in your final project, I fully intend on working with you one-on-one with NumPy, SciPy if you guys need it for your projects. What I didn't want to do is because we have a wider range of majors in here, I don't want to spend all that time on something that somebody in cybersecurity isn't necessarily going to touch. But everybody should be familiar with those packages. All right, anybody have any questions in the class as a whole? Where we're heading, what we're doing? All right, again, we'll have the project requirements will be out to you for NumPy, SciPy. That'll be out here on Thursday. Next week is when we start working with those data frames in order to display things out in pandas. And so we'll take a bunch of data in with pandas. We'll write that out as both on the screen, but then we'll also write it out as I think I have it set up to write out as a PDF document as well as an HTML page. So we'll do some cool things in working with the data frames. And then from there, we get the fun stuff, which is really working with the web frameworks. That's going to take us much more time. That will lead us up into the rest of the semester. All right, that's all I got for today.